Good afternoon, ladies and gentlemen. Welcome to Math 20-1, Chapter 8, Lesson 5, the last lesson of the course, graphing reciprocals of quadratic functions. Now, recall from 8.3, for the function y equals f of x, the reciprocal is 1 over f of x. Now, in 8.3, you graphed linear equations and the reciprocals. Now, we're graphing the reciprocals of quadratics, like 1 over x squared minus 4x plus 3. That's hard, but graphing y equals x squared minus 4x plus 3 is much easier. So, let's do a different example here, like x squared minus 3x plus 2. Now, can you guys graph that without my help? Yes, you can. So, I've done this for a long time. By now, you're all going y equals clear x squared minus 3x plus 2 x squared, you shazbat. It's supposed to be x squared minus 3x plus 2. Graph it, and we get something like that. Now, as I said, that's pretty straightforward. By now, you should be able to factor this. What are two numbers that multiply together to be 2 and add together to be minus 1 and minus 2? Which means when you solve this, you're getting 1 and 2 would be your x-intercepts, or solutions. Anyway, but enough about that. Let's just look at the table of values, because it's so much easier that way. All right. Minus 20, minus 12, 20, 12, 6, 2, 0. 20, 12, 6, 2, 0, 0. That'll be 2. Okay. So, 2, 2, 6, 6. So the parabola goes something like that. Okay. Now, once we've got that, we can, of course, graph the reciprocal. 1 over 20, 1 over 12, 1 over 6, 1 over 2, dne, dne, 1/2. Now, right off the bat, wherever our original function is 0, that is our x-intercepts, that's where we're going to have our asymptotes. So we have two asymptotes, one right here and one right here. Now, plotting some points. Let's see now. 3 is 1/2, 1/2, 1 minus 1. All right, so it's going down like that. Now, a few things. Here, the original graph is getting big. What's the reciprocal of getting big? Getting small. Now, from where y equals 1, the original function, the original function is getting smaller. What's the reciprocal of getting smaller? Getting bigger. So we know the reciprocal is going like that. Now, this is symmetrical, so it's the same thing on the other side over here. This graph is getting bigger, the reciprocal getting bigger is getting smaller. And from here, the graph is getting smaller, the reciprocal smaller is getting bigger. So far, so good? All right. Now, what do we know down below? Well, in between, we're missing a bit. And notice this bit down here is negative. So what's the reciprocal of a negative number? Well, it's going to be negative. But this is a fraction less than 1. So what's the reciprocal of something less than 1? Something bigger than 1. Do I know exactly where? No. But it's something like that. Now, of course, let's double check our answers. Now, the best way to do this, I think, is x squared minus 3x plus 2, close bracket, and the negative 1 button. That's the reciprocal. Okay? And then I hit graph, and there we go. And yes, see down below the little U shape pointing down? That's for the reciprocal. Let me change this. Make this a fat one. And there we go. So actually, yeah, It's something like this. Now, when I ask you to draw this from the original graph, you will always have your graphing calculator. So, and honestly, graph it on your graphing calculator first so you know what the actual answer is. Okay? Now, a couple things to point out here. If I give you the equation, you can figure out the reciprocal. 1 over x squared minus 7x plus 10. Now, the non-permissible values, x squared minus 7x minus 10 can't equal 0. Squared minus 7x minus 10 cannot equal 0. Plus 10, sorry. That's x minus 2, x minus 5 cannot equal 0. X minus 2 can't equal 0. X cannot equal plus 2. X minus 5 cannot equal 0. X cannot equal 5. So my non-permissible values are my asymptotes. Are, just solve the quadratic. Now, same thing here. X squared minus 4x plus 4. And reciprocal is 1 over x squared minus 4x plus 4. And x squared minus 4x plus 4 cannot equal 0. I believe that's x minus 2 squared cannot equal 0. Take the square root of both sides. X minus 2 cannot equal 0. X cannot equal plus 2. The next one, the reciprocal, is 1 over x squared minus 4x plus 3. So the original is x squared minus 4x plus 3. And my denominator, x squared minus 4x plus 3 cannot equal 0. That is x minus 3 times x minus 1. And x cannot equal plus 1 or plus 3. Okay? Now, the first three are fairly straightforward. I don't need you to show me all the factoring. Actually, I don't need you to show the factoring work. I need you to be able to do it. Now, the fourth one, 1 over x squared minus x minus 20. Well, the original function is 12x squared minus x minus 20. And, oh, poopy. I got to factor that damn thing. Okay, well. You guys can just look at it and go, oh, that works. So 12x squared minus x minus 20. And the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Factors of minus 20 are minus 1 times 20, or 1 times minus 20, minus 2 times 10, or 2 times minus 10. Can't divide 20 by 3. You can divide it by 4. Oh, crap. 3 choices for the first and 6 choices for the second. Okay, now, doing some of these, you'll notice patterns. Now, I will point out, right in the middle there is minus x. Minus x is not a big number. So I don't think, let me stress this, sorry, let me rephrase this. Right here, the minus x is not a big number. So I don't think you're multiplying stuff by 12 or stuff by 20. So right off the bat, I'm going to put a line through that. And 10 is kind of big, and so is 6. So I'm betting it's 3 and 4, and some combination of 4 and 5. So now I'm not certain, but I'm eliminating some possibilities. So let's go 3x, 4x. Now, my head times, okay, if I go minus 4 and plus 5, and that is minus 16x, that is 15. Yes, that works. So you see, we can eliminate some possibilities. So this is actually 3x minus 4, and 4x plus 5 cannot equal 0. So 3x minus 4 cannot equal 0. That means 3x cannot equal 4, x cannot equal 4/3, And 4x plus 5 cannot equal 0. 4x can't equal minus 5. X cannot equal minus 5 over 4. So we're getting fractions. Okay. That one's annoying. Doable and a good reminder, but annoying. Now, that leads to the last one. X cannot equal 5 or 1/4. Well, x cannot equal 5. Subtract 5 from both sides. One of the factors is x minus 5. The other factor, x cannot equal 1/4. Remember, with a fraction, you multiply to get rid of it. So 4x cannot equal 1. Oh, sorry, times 4, multiply both sides by 4. And subtract 1 from both sides, so you get 4x minus 1 cannot equal 0. So that's my denominator. X minus 5 times 4x minus 1. Do I have to multiply it out? No. Can I? Yeah. Do I want to? No, I'm lazy. So I'm perfectly happy to leave this as x minus 5 times 4x minus 1. Now, if you want to multiply it out, go for it. I have no problems with that. I'm just economical with my energy. Okay? So, note here, a little bit of factoring. Your asymptotes are the non-permissible values of the reciprocal function, which means you have to be able to find the original equation and factor it. So, looking at this one, minus 1/2 x minus 3 squared. So, think back to chapter 3 or 4. A x minus p squared plus q. So, this is 3. Sorry. So the, oh God, getting old. The vertex is at minus 3 and 0. Sorry, plus 3. Oh, dear God, help me. X minus p. So that means it moves to the right 3. So the vertex is at 3 comma 0. Now, the minus 1/2. That is, you should be able to remember the minus means it opens down instead of going up. And remember, what does the parabola look like? Over 1, up 1. But instead, this is going over 1, down 1/2. Over 1, down 1/2. Over 2, up 4. What's half of 4? 2. So it's going down 2 instead of up 4. Over 3 is supposed to be up 9. But it's going down half of that. What's half of 9? 4.5. 2, 4, 4.5. Oh, over 4 should be up 4 squared or 16. Half of 16 is 8, and it's going down 8. 1, 2, 3, 4, 5, 6. It doesn't fit. All right. So there's my parabola. Now, I did that in my head because I've been doing this without graphs calculations before you were born. What you guys should be doing right off the bat negative 0.5 bracket x minus 3 close bracket squared. Graph. Just what I did there. Now, I did that in my head. You guys should be able to do it in the graphing calculator. Can you do it in your head without a graphing calculator? Maybe. But honestly, I wouldn't expect you to. But can you do a table of values? Yes, you can. Now, I'm also lazy. I'm just going to copy out my table of values here because, God help me, I'm getting old. All right, 18 minus 12.5 minus 8. Minus 18 minus 12.5 minus 8. The 0, 1, 2. Minus 4, 5, 4.5 minus 2 minus 1/2. Minus 4. Sorry, try that again. 4.5 minus 2 minus 0.5. 3 I'm hoping is 0. Double check. Yep. And then it's going the other way, so I did get it right. All right. And remember, with a quadratic, it has an axis of symmetry right down the middle, which means you only need half of it and do the reflection. Anyway, so the domain, x is all real, and y is less than or equal to 0. That you can all read off your graphing calculator. So 1 over minus a half bracket x minus 3 squared. Well, that's minus 1 over 18 minus 1 over 12.5 minus 1/8 minus 1 over 4.5 minus 1/2. Now, minus a half, that'll be minus 2. Does not exist. Okay, so I have an asymptote right down the middle. Where the original function is 0, I will have a does not exist or asymptote. Now, 2 is 2. 1 is minus a half, so it goes something like that. Now, note here, I've mentioned this before, and I'm going to mention it again because I'm weird like that. What is the reciprocal of minus 1? So anytime the original function is minus 1, the reciprocal will equal minus 1. So I actually have several points I can graph. Now, we've done enough of these to know this is going down like that. This original function is getting smaller and negative. The reciprocal of a small negative number is a large negative number. And we do the same thing on the other side. This gets smaller. Let's go to 2. It's going to go something like that. So there's my reciprocal function. Now, am I right? I hope so, because I hate embarrassing myself in front of you guys like this. But let's just graph it to be on the safe side. Bracket negative 0.5 bracket x minus 3 close bracket squared close big next bracket to the negative 1 graph. Yes, there we are. And it works. Oh, domain and range. Domain. Oh, you poopy head, stop that. What is your issue? Stop that. Stop that now. X is all real. And somebody's going to point out x cannot equal 3. All right? Because I have asymptote or non-permissible value. Now my range, y is still less than or equal to 0. Sorry. Oh, picky. Sorry, you guys made a boo-boo there. Less than 0. Because what's going to happen here, this original function is getting bigger and bigger and bigger. Huge. What's the reciprocal of a huge number? 1 over a huge number is not 0, but getting close to 0. So this graph will get closer and closer and closer to 0, but it will never touch the x-axis. So we actually have a horizontal asymptote right here. It's just hard to see. As I said, I'm not worried about the range and the horizontal asymptotes now. That's something that becomes important in calculus. And to a certain extent in Math 30. I'm just showing it to you now so that it's not a complete surprise next year. So, without using your graphing calculator, can you graph the original equation and can you graph the reciprocal? And yes, of course, I fully expect you to graph this with your graphing calculator so you know what the actual answer is. So, I'm just going to graph this without using the original equation, and while you guys frantically graph it using the graphing calculator, which is fine. So the original equation, x plus 3, x plus 1. Now, minus 1 and minus 3. I know my y value would be 0. Those are my x-intercepts. X is minus 2. Now, I'm doing this in my head while you guys are graphing this. Minus 2, that should be 191. That'll be minus 1. 0 will be 3 times 1 is 3. 4 times 2 is 8. 3 plus 2 is 5. 3, 5 3s are 15. Now I don't care about 3. So we'll get a graph like this. Minus 1 is going to be 3. And it's going to keep on going. So the original graph goes like this. Symmetrical, it's going to be like this. Now, by now you should have done this. Bracket x plus 3 bracket x plus 1 close bracket graph. Yes, as I said, check with Mr. Graphing Calculator just because. I fully expect you to have this done already. All right? Now, that's the straightforward part. Domain, x is all real, y is greater than or equal to minus 1. Okay? So, what about the reciprocal? Well, right off the bat, where's the original function cross the x-axis or have x equals 0? Got minus 1 and minus 3. So right off the bat, those are going to be my asymptotes. So if I start talking about domain and range, domain, x is all real, x cannot equal minus 1 and minus 3. That I need you to be able to tell me. The range, I'm not worried about. Now, what else can we say? Now, by now, you've drawn the reciprocal graph on your graphing calculator and you know the answers. But I want to stress this, where y equals 1 and y equals minus 1, the reciprocal of 1 is 1. The reciprocal of minus 1 is minus 1. So I know where my reciprocal graph is going to be. Now here, the original graph is getting bigger. What's the reciprocal? What is the reciprocal of getting bigger? Smaller. So it's going to do something like that. And the same thing here. This is getting bigger, so the reciprocal is getting smaller. Now, in between, now notice y equals 1 is an important cutoff point. Below that here, this is getting smaller. What's the reciprocal of a smaller number? A bigger number. A bigger positive number. Same idea here. This original graph is going to 0. The reciprocal is getting real small, getting real big. Now, what about the middle part where it's below the x-axis? Well, same idea. Here, the graph equals minus, sorry, the original graph equals minus, ugh. Good morning, Mongo, speak English. The original graph, y equals minus 1 right there. So the reciprocal of minus 1 is minus 1, so the reciprocal graph will be at that point also. What happens when it leaves? Here, the original graph is getting smaller, negative. What's the reciprocal of a really small number? A really big number, so it's going to go like this. And same idea over here. So that will be my reciprocal graph. Now, once again, I don't care about the range. I'm just pointing it out because in Math 30-1 and calculus will become important. But here, notice y is greater than 0 and y is less than or equal to minus 1. If you've got that, great. If you don't, really don't worry about it. I'll talk about it a lot. I'll talk a little more in Math 30-1. Right? That's more of a bonus point question if you can get it. Okay. Now, can you graph? Oh, sorry. My apologies, ladies and gentlemen. We should always, always, always check our equation. Did I bung it? Because poop happens. Now, the original graph was clear. Oh, poopy, I'm having a brain fart here. Oh, it was that one. X plus 3, bracket, x plus 1. I apologize, ladies and gentlemen. I'm getting so old. Now, a little trouble putting this in your graphing calculator. I suggest 2 sets of brackets. X plus 3, bracket, x plus 1, close bracket, to the negative 1. We have to put both terms to the negative 1, or we get a very different equation. Enter graph. And there we go. And there we go. So you can see the reciprocal. Looks like we got it. All right, I'm happy. Now I believe there is a couple more. Yes, one more question. We do this. Now, I was going to say There's one more part to this. If I give you the graph, what does the reciprocal look like instead of the equation? That's my last couple examples. But now I'm going to do this one more, graphing using the original equation thing. If you've got this, go on to the next example, please. All right. Anyway, graph y equals 1 over 2 times x plus 1 minus plus 3. So that's a, p, q. This is a vertex at, remember it's x minus p, so this is x minus minus 1. So I have a vertex at minus 1 and 3. And then what happens? Okay, the a value is twice as much, which means it goes over 1. And instead of up 1, it goes up 2. It goes over 1, goes up 2. Goes over 2. 2 squared is 4, so this will go 8, twice as much. So there's the original function. Right? So far, so good. That you should be able to do. And yes, you've already graphed in our graphing calculators, so you know I'm right. But I'm getting old, so I'm going to double check, because God help me, I hate this getting old. Y equals, clear, this is 2 bracket x plus 1 close bracket squared plus 3 graph. Oh, I'm sorry, I still have my original reciprocal down here. Clear. Graph. There we go. So, I got it right. Woohoo! Now, domain, all right. Now, what's my reciprocal going to look like? Well, note the original function. Is there any point where it crosses the x-axis or has a zero solution? No. So there's going to be no asymptotes. Okay? No asymptotes, which means domain x is all real. Now, the next question is, what the heck does this graph look like? Well, I know my point here, minus 1 and 3. So, if y equals 3 here, what's the reciprocal of 3? 1/3. Now, I can take some more points if you want. This is 5. What's the reciprocal of 5? 1/5. Now, the way I need you to think about this is this graph is going up, getting bigger. What's the reciprocal of getting bigger? Getting smaller. Same idea here. This graph is getting bigger. What's the reciprocal of getting bigger? Getting smaller. So I get a lump. Now, I sometimes refer to this as a pimple, but you guys, yeah. You guys, some of you still suffer from pimples or acne, and it's not good. Now, what's the range? Don't care. If you want to get picky, the highest value is 1/3. But once again, I don't care about the range. I don't really care about the range. I'm just introducing it to you so you can, so it's not a complete surprise in Math 30-1, because it is one of the first things we do in September. Now, that's reciprocal. Did I get it right? I don't know, because I'm just getting old. So let's try this again. Bracket, everything in, oh no, you shazbot. No, that's supposed to be 2. Sorry, that's supposed to be 2, never mind. Enter. Put it in correctly, Mr. Sutton. That always helps. X plus 1, close bracket, squared, plus 3, close bracket, and minus 1. Make this a thick one. Graph. Yeah, it's just a lump. Now, you'll note here, it looks pretty flat. Do not ever hit zoom. Maybe make your... There we go. Now you can clearly see there's a lump there. Notice I made my y value to minus 1 to 1. If I made my window, say, 0 to 4, so we can see the graph. Yeah, you can see here's my original parabola, y equals 3, and here's my lump down here at about 1/3. Okay? So, see how that goes? Good. Now, if you got problems with that, watch the video again, do some more practice, and remember, please, if I give you an equation and I talk about graphing, graph it in your graphing calculator right away. Even if I say, use the original equation, use the original graph, graph the damn thing on your calculator so you know what the actual answer is. Now, last thing, is what does the original graph look like? Okay, so here's the graph of a reciprocal function. This is y equals 1 over f of x. What does the original function look like? Well, offhand, I can tell you here, right here, the original function, f of x, is 0. That is, where the asymptote is, the original function is 0. And remember I kept harping on about y equals 1 and y equals minus 1? That's where your new function, or your original function, was 1 also. So all of a sudden we have 3 points. Now, since they're curving up like this, we've seen enough of these. Start drawing the lines. Go like this. Now this is going up like this, so it's some sort of parabola. Now, do I know exactly what it is? No. We are going over 1 and up 1, which suggests a value is 1. Now note, I'm not making you come up with the equation for this. No. I want you to be able to draw the parabola for me. Okay? So far, so good? All right. One more example. Now, the original function, you don't know, but the reciprocal function looks like this. Now, the original function, sorry, there are asymptotes here and here, which means that the original function f of x is 0 there. Okay? Now, if I have to say it one more time, it'll be an even 100 times when y equals 1, or when y equals minus 1. That's where the original function and the reciprocal cross. Now, you'll note here I did throw in 1.2 comma minus 1/3. So this is my y value here, minus 1/3. What's the reciprocal of minus 1/3? Minus 3. Now, I am not asking you to come up with the equation for this, but can you play connect the dots? Some sort of parabola like this. No, I do not want the equation. I'm not going to ask for the equation. Don't do that. Too much work. All right? But there we go, and that's what the original equation looks like. So you guys okay with that? I hope so. If you're having problems, shoot me an email. Otherwise, I'll see you in class tomorrow and do the check your understanding questions. Good luck. Good luck.